Hi everyone. Today we are going to start with the inner planets. So in order to get to the notes, please make sure that you scroll down to view more. And then you will be looking at our notes and planets and our solar system. As we go through the notes, please make sure that you are filling those out. Again, we are starting with the planets of our solar system, and today we will be working on the inner planets. So we're going to go all the way through to the asteroid belt today. All right, so our planets and the dwarf planets of our solar system, definitely check out this link as it's a nice overview of the planets and our solar system. All right, so our solar system includes the sun, 8 planets and their moons, dwarf planets, the asteroids, comets, and meteors that surround it. All of these objects orbit the sun, and it is called a solar system because this area of space is where the sun's gravity is dominant. So we're all kind of staying in place in where we are at because of our gravitational pull and association with the sun. We have 2 different types of planets in our solar system. We have our inner planets, which we'll talk about today, and we have our outer planets, which Ms. Laporte will talk about in the next presentation. Our inner planets are terrestrial, so that vocabulary word meaning rock and mineral surface. Okay, so you can stand on the surface of those planets. They're small with few or no moons. They have a slow rotational speed, and they are dense. Now, this is where we have a good compare-contrast to our outer planets. So even though on our inner planets, we're able to stand on them, if we're able to get there and survive those conditions, we'd be able to stand on them. However, on the outer planets, they are mostly made out of gas and ice. They are called the gas and ice giants, and they're mostly hydrogen and helium, and they are not solid. They are large with many moons, which some of you will be able to see here later. And they have fast rotational speeds. They have low density and a thick atmosphere. And as we go through these planets, you'll see that we'll do a lot of comparison to our planet. So when we're talking about the days and the lengths of time, you'll notice that we're comparing them to our time here on the Earth. All right, so Mercury is the swiftest planet. It is about 58 million kilometers from the sun, and it is the closest to the sun. One rotation on its axis is 59 Earth days. And that's a little bit different than one day-night cycle. One day-night cycle is 175.97 Earth days. 1 year, okay, so this is the shortest revolution around the sun, is 88 Earth days. The largest metallic core, 80% of its radius. The surface is battered from meteoroid collision. The temperature ranges from the daytime being 430 degrees Celsius, or about 800 degrees Fahrenheit, to at nighttime where it can get as cold as negative 290 degrees Fahrenheit or negative 180 degrees Celsius. It has a very, very thin atmosphere, and it contains no moons, or has no moons. And actually, Mercury is about as small as our Earth moon. We can also take a look at this link here. We click on that. It will take us to some more information about Mercury. So here's where we can find some more information about Mercury and what is some information about it. This will work. There we go. Okay, so we've got our overview here, which talks us a little bit more about Mercury. We can get a little bit more in depth. We can look at it by numbers, as well as we can look at some photos of it too. So this is kind of cool. We've got that comparison, which you will see you'll be doing a little bit later, where you can kind of see here's Mercury, here's the Earth, and you'll be doing some compare-contrasts in a project later next week or the week after. So that, and then there's also some gallery pictures, some explorations, what have we explored looking at Mercury, but these are some pretty good things to kind of just sift through when you have some time, when you are kind of sitting and chilling, or when you are doing the last project for us. Okay, all right, so back to our planets. Next, we have Venus. Venus is the hottest planet. It is considered Earth's evil twin. It's about 108 million kilometers from the sun. One day is equal to 243 Earth days. So this is the slowest. So for one day for it to rotate on its own axis, it takes 243 Earth days. And the thing about Venus is that it is in retrograde, so it actually rotates backwards. 1 year on Venus is equal to 225 Earth days. So if you take a look at those two numbers there, you kind of see that it takes longer for one actual day than it does for an entire revolution around the sun, which is 225 days. It is a solid surface with craters and volcanic landscape. Temperature ranges or is an average of 900 degrees Fahrenheit. And the reason why it is so warm there and so hot is because it has a thick toxic atmosphere containing carbon dioxide, nitrogen, sulfuric acid, and hurricane force winds. Venus does not have any moons. Earth. So Earth is 150 million kilometers from the sun. And we know that one rotation is 24 hours and 1 year is 365 days. It has a metal core, a solid dynamic surface with plate tectonics, which we didn't get to talk about this year because our geography part of our year was hit with our coronavirus. So plate tectonics is a shifting of our surface. That's what's creating our mountains, what's creating earthquakes, as well as our volcanoes that we see here on Earth. The axial tilt is what creates our seasons. So we know we have that tilt that we talked about. And then it is mostly covered in water. The surface supports life, and the temperature ranges about 61 degrees Fahrenheit. The atmosphere is 78% nitrogen, 21% oxygen, and it protects us from meteoroids. And then we also have one moon, and I love this picture down here in the bottom left part. That is a picture taken from the moon looking at Earth. So that one I really like a lot. I forgot about Mars. So Mars is the last planet we will talk about today. Mars is the red planet. It is 228 million kilometers from the sun. One day is 24.5 Earth hours. So again, one day is 24.5 Earth hours. 1 year, though, is 687 Earth days. All right, so the day is just about as long as our day. However, their year is almost twice the amount of our years here on Earth. A solid surface with craters. It has desert and volcanic mountains, the plate tectonics as well, which I kind of just discussed. And it is red due to the oxidized iron in the soil. It has polar caps, frozen carbon dioxide, and it also has an axial tilt, which means that it also experiences seasons. The temperature average is negative 55 degrees Celsius or negative 67 degrees Fahrenheit. It has a thin atmosphere, which is causing it to be cold. That atmosphere consists of carbon dioxide, nitrogen, and argon. And it actually has two moons. So like Earth, we have a moon, but Mars has two moons, Phobos and Deimos. And then the last thing we'll talk about is the asteroid belt. So the asteroids are rocky, airless worlds that orbit the sun, but are too small to be considered planets. There's tens of thousands that are located in that main asteroid belt between Mars and Jupiter. So if we go back a couple of slides here, you'll see that asteroid belt right here between Mars and Jupiter. So those are our slides today. Please make sure that you are filling out your notes and make sure that you are going through and looking at any videos or anything with those asterisks. Again, it's nice to kind of go in and look on NASA website at those planets to get a little bit more information. Like this one here, this was our Mars overview. It gives you, some kind of cool information about the distance that it is currently from the sun. It'll give you some more information about the core. And it does take a little bit to load up, so be patient, which I am not at the moment. Be patient with it loading. It will give you some cool background information, just like it did with Mercury.